Hello. And today, once again, we are going to work on Kast, the programming language. So yesterday I started trying to work on the macro hygiene, but I did not make it. So today is hopefully going today hopefully this is going to be done, because macro hygiene is a nice thing to have. So the idea is that if we have a macro, so macros are just things that are returning AST. Const macro is inner AST returning AST, and we return the AST, right? Something like this. Let x be 1 to 3, and then we just do inner. Let's just do, ppg print x and inner, something like this. And then we call this macro by having x as the argument here. So all of the AST is x, and then we just say x is, let's call this x in macro definition, and this x is x out, I don't know, let's say global x global, for example, right? So this should print this should print x in macro def. Oh, this is too big now. X global. Guess we can do this. All right. If we try right now in our examples test, so I have this example. Let's create a dedicated example for the macro hygiene. Macro hygiene, right? Yeah, let's just say that AST is AST. We're going to try to do this without std, right? Like this. Wait, what? Why does this not work? Kast, run, no STD examples, macro hygiene. Is that not how the shebangs are supposed to work? Which file or directory is not found? Or like this cannot have any arguments in the shebang. sh c cast run no std. Is that what they want me to? Oh, we can do -s, right? In env. No, it's just command and then args, right? What is -s? Split string. Process the string as into separate arguments used to... Okay, I see. Env s. Like this. Okay, that works. Alright, apparently. Nice. Okay. So this is the part of the standard library. Part of the standard library, we're going to implement syntax macro arg as include ast macro arg. Like this, right? Dun, 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 dun. Couldn't find dbg in scope. Yeah, let's also say that dbg is print is txt into native dbg print x. Okay, there we go. So this actually prints x is macrodef and x global, which means that this works. But so yeah, because I was doing something yesterday, before yesterday it did not work. So if I do git stash, I guess. And then I try run this. It doesn't work because there is no native AST. Yes. It's dash pop. And to like commit something at least. Right. So in the standard library, we now have the AST. Let me just do this one specifically. And in the natives, over here we have the AST, right? Okay. Native, okay, std AST type. Okay, then after that I can stash and I can try running this example. And yes. And it was printing the x in macrodef and x in macrodef twice. Hello, Loki, Abu. Right? So this means that this X was referring to this X, basically, while it should not. Right? So if I go to the definition of this, it is this definition, which is wrong. So that's why... That's what we are doing. But there is still some bugs, I guess. What we're up to today. I'm going to finish the macro hygiene that I started yesterday. And maybe we will look into something else about the macros. Like maybe I start trying to do the derive macros. That's what I want to use the macros for, I guess, to derive, to generate some code, right? That's what macros are for. And we want to generate the implementations of traits. Like, for example, for printing a type, we don't want to write the boilerplate code, which I right now do in my OCaml, for example. This over here is 1,000 lines of code, which is just boilerplate of how to print all the different things in my language, right? This could be just generated code. So yeah. In Rust, it's called derive macros. I know that there's features available in other languages too. I'm not sure how Haskell deriving works, actually. How does Haskell deriving works? How to write a custom deriver. I'm not sure if they are actually generating the code there or not. Deriving is Haskell is a compiler trick. GHCC is deriving Axio and manufactures instances for you, but only very specific hard-coded ways. You don't get to invent the new derivations. No? Wait, no. There are ways to do custom deriving. There is generic-based deriving. Derive generic. The instance uses generic under the hood. Libraries like ASIN, binary, hashable do this. This is how most automatic deriving actually works. And then deriving via. Derive as if it was another type. Okay. Actually, this is something that is missing in Rust, I think. That is nice. You only have this in some custom macros, like for Serde, for example. You cannot extend the deriving keyword itself. What you can do instead of you can derive via generic. So a generic is a trait, I'm guessing, a type class in Haskell. But doesn't that mean that the code is like you just work with some polymorphic interface? Which means that the code is... You don't really like... Write a type class with a generic default. Type class my class A, where method a int and default method. Generic gmy class. Extremely powerful, extremely annoying. Haskell generic deriving. Data type generic functions are based on the idea of converting values of data type T into corresponding values of isomorphic type rep T. The type rep t is built from a limited set of type constructors, all provided by this module. So yeah, basically it's kind of like this SERD data model, right? So when you implement your own serializer with SERD, you serialize the SERD's internal representation. I'm guessing that over here, this rep t is like internal representation of the type, right? Kind of. Generic representation type. And this is the associated type, actually. Rep a star into star. Bam, 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 bam. So let's look at this example first. Data tree A. So you create a type tree, which is either a leaf or a node with two left and right subtrees. You derive the generic. The above declaration causes the following representation to be generated, right? So you have a class and you have the associated type. How do you represent the tree? And there's a bunch of like magic symbols here, right? Yeah. You can obtain information about the code being generated by passing the dump deriv flag. In GHCI, you can expand a type family like this. There's D1, C1, S1, and they mean something. Beautiful names. Yeah, but what this means is basically that they don't do code generation in Haskell, but instead they give you some way to inspect the type, I guess. But deriving the generic is like giving you this representation, as giving you a way to do the reflection, I guess, type reflection. And then if you have the reflection data, then you can provide the implementation of your actual trait based on this, which is nice, I guess. But it also means that the code is going to run at runtime, not at compile time or something, maybe. Anyway, we'll look into the actual deriving later, because first I need to solve the macro hygiene. All right, so this example works. This example actually works. Right, it prints what is needed, but the example that is not works. So like if I try to do this, let's just run Kast, right? So we have these things. There are certain things that are not working, and I think all of these is actually the loops. So what this complains about is that this x is not found. This x is supposed to be this x from inside of this for loop, but it is not found. Why is it not found? Because this over here is also a macro, and it's trying to look this up in a different scope than needed. You need some nasal hygiene. done. Hello, coffee lava. No, it's fine. What I should do is probably clean up my table a little bit. Maybe it's a little bit too dusty here. Hello, little boo. Hi. Coffee lava.
Hello,
Use
Betsy.
Jai. Which means that I probably might want to ask a question, but... What question? In fact, I had the need for unhygienic macros before. Unhygienic macros are also useful. Yes. I actually have that too. So like it is useful sometimes. Yes, I because I realized that I need it. At least I need to try it now. I created a new syntax which is called no hygiene. Which disables the hygiene of the macros. I do it right now to implement returning from functions, because in order to return from functions, it's not a built-in language feature, but it is instead it is instead like labeled blocks which you can break out of. I call this unwindable mechanic, right? So in order to unwind to the specific block, I need to remember its label, which means that it's going to be like just a variable. And because this is working through across like two different macros and they need to see each other, I'm doing this with no hygiene. Another way to do this is do the compile time context, but there are issues with the typing in that. So it needs more work. So ideally, I still do this with the hygienic macros, but then I need other features. I'd never use them in production, but very useful for tests. You know little about Jai, just using it like C, but I can try to answer. I cannot come up with a question. Maybe at some point. I should have. I just I don't know. I feel like I will just want to try Jai myself maybe when it releases. It's going to release this year for sure, right? Jai release date November 2025. Jai film. Wait, what? There is a movie about Jai already? Couple months after his game fake. Yeah, but his game is releasing this year, right? Or is it not having John Blow game release date? Yeah, I could not remember this name. This name is too long. It is going to be released in 2026, right? Yeah. But there is no release date announced yet. Yeah. I just think that Jai is having a lot of features which are very similar to my language. I'm focusing more on the high level stuff, and Jai is focusing more on the low level stuff. But in general, you also you said that you can like write a borrow checker in Jai. Even although Jai doesn't have the borrow checker, you can implement it. Is that actually true, or no? Because I feel like for the borrow checker, there needs to be extra information. That like I feel like it should be done on the language level. Real men have borrow checker in their mind. Yeah. Yeah, if you are a real programmer, then you can always just keep your entire program in your head, so that, like, you know, you never make mistakes because you remember everything, right? How much lines of code is there in John Blow's game? Wasn't it like 100 billion lines of code, and then it compiles with Jai in like under a second or something? So yeah, the fact that he doesn't need a borrow checker for that is impressive, I would say. But then again, you see, fans, you write code in a different way than I'm writing code, I think. Completely. So, yeah. Right, anyway. So I have a problem where my loops right now are not working anymore. I broke my loops by implementing the macro hygiene because I implemented it incorrectly or something. Is Jai like chai in the way that Java is like Java coffee? After writing Rust, you start to see lifetimes and borrow, copy, move mechanics in other languages. Rust made me a better Go and TypeScript programmer. Well, yeah, but you still, like, so my reasoning that it still is a useful feature, and I would rather have it than not have it, is because I don't want to think about it myself. I want someone to help me. Like, the more help the compiler is giving to you, the better. The more things are checked at compile time and not at runtime. And sometimes at runtime your checks are gone and you just sec faulting, right? So catching the error as early as possible is just always better. Hello, Death Razor. Three streams open and the same ad echoing. All right, so why is this not working, right? Because here is my test that I was doing. So this is a different test than my macro hygiene. Maybe let's move this into the macro hygiene actually, so that we test that this works still. So let's say that I will use a for loop, but I will do a for loop differently. I do a different desugaring. So this is not a real for loop. We just are going to have our iterable as a tuple with fields x and y, and we're going to just call the body with these two fields, right? So this is the loop of the body of the loop. Loop body is basically this. So we are assigning the value to the pattern that we are like writing here, and then we just inject the body over here, right? That is it. So if I try to run this right now, this is going to print x global, because this is actually now referring to our old x over here, which is wrong. Let's make this two separate scopes at least, so that this x is not this x at all. It should not be found. So why is this not working, right? That's what we need to figure out. So how does macro hygiene actually work? The idea is that when you resolve the symbols, you resolve them on the lexical scope. But what is this code actually being rewritten into, right? This is being rewritten into this, right? Let's just do it like that here. So so the pattern is just X, right? And the body is just this, right? So if we just substitute the body, and this is my value, which is being substituted like this. So this is the code that's being generated, right? So obviously this X should be found, but it is not found. Why? Because when we're substituting, we are also remembering that this X was actually came from this scope where this macro was invoked, right? To distinguish it from a different X that I could write here, right? Like this X and this X, these are different X's. So this is X from this scope, and this is X from this scope, right? So basically, we are maintaining multiple lexical scopes when we are generating code. Because whenever I am injecting the AST, which is the result of me calling a macro, right? This AST was created in this scope. So lexically, the symbol resolution should work based on this scope. But then when inside of this AST, we are having another AST which came from a different scope. Now inside of this AST, the symbol resolution should work based on the original scope where this AST came from. Which basically means that I am maintaining multiple lexical scopes in the compiler. So yesterday when I was implementing this, I thought I would need only 2, but I think in fact we do a lot of like the amount of lexical scopes that I need to maintain is basically the depth of the macro invocations. Right? Hello, Ray March. So let's say that over here, I need to like, you know, let's just say that you know, let's say like assign pattern be value, for example, right? And this assign is a custom syntax. Assign assign pattern to be value, and this is going to be just implemented assign pattern be value. This is going to be just implemented as you know, let's call it like, I don't know, let's call it like custom let for whatever reason, right? So custom let is just going to be replaced with a normal let pattern be value, right? And we do a custom let here. There you go, right? So this means that over here we are injecting, we are invoking this macro, we're generating this AST, and inside of this AST we have this thing which generates this AST, and inside of this AST we have the original AST, right? So we have like 3 levels of so like basically we have 3 different scopes in which this symbol could potentially be resolved. It can be resolved based on this scope, based on this scope, or based on the original scope in which the macro was called. And then in this generated code, I am also... Why is VS Code shaking? I don't know. Does your VS Code not shake? Oh, and you type code. I don't know. Maybe I'm hitting my keyboard too hard when I'm pressing the the keys, you know. So yeah, inside of the generated code, we sometimes open new scopes, right? For example, over here, we are generating a function. Inside of this function, this is a separate scope, right? So now, now this scope is also going to be 3 different scopes. So whenever I open a new lexical scope, I need to open a new lexical scope for every macro invocation like site, you know, because inside of this we still can refer to symbols from 3 different places depending on like the things. I don't know how to explain this properly. But yeah. So here's what it looks like now. We have in the compiler state, here's my scopes, right? So we have the call site. Call site is basically the final macro expansion site, and then definition sites is all of the different scopes in which the macros were defined. Or it's not like about the macros, it's about where the ASTs were constructed, but you usually construct them inside of a macro, right? So yeah, wherever you defined the AST that is being injected into the current call site. So we have for each of those, we maintain a separate scope. Whenever I'm entering a scope, I'm entering I'm creating a new child scope for each of those. Hello, Nigel. Actually, I did. Actually, yes. All right. So yeah. How does this work exactly? So now over here, or I guess in the other places where I use my macros, I am just resolving the symbols that already exist. But in this case, this is a pattern, which means that this is introducing a new variable. All right, because this is a pattern. So the question is, in which scope this needs to be, this variable needs to be created. So it should be the scope that is tied to the call site of the macro, right? But it's not exactly that call site because we are still supposed to be inside of a loop. So the way I'm doing this here is whenever I want to make sure that... So I know the definition site of this X, which is this original scope, right? And then if I'm currently not maintaining the dedicated scope for that definition site, then I am going to create a new scope with parent being that definition site. And that's what I'm going to track, is the idea. Does that make sense? So specifically, right? This over here is the code that we generate. This over here is the code that we generate. So in which scope is this X is defined? That's the question. I don't actually define it in this scope, but I define it in the new scope, which is kind of like adjacent to this for loop over here, right? So this is the, you know, let's call this like I don't know, X scope, right? So the scope of x is over here, and then I'm basically creating this variable inside of this extra scope, which is adjacent to this loop, just for the sake of simple resolution. So we say x is equal to value, right? But the value in this case is coming from that place. From actually this scope. So it's a little weird, but that's what we do. So because I have not seen anything that came from that scope previously, I'm creating this scope over here, right? And then when I'm trying to print x here, x should be looked up in this scope, not in this scope. And it should be resolved properly. This is lexical scopes, by the way. We don't care about the values. For the lexical scopes, we basically... a lexical scope is basically resolving a string into, like, the concrete, like, symbol, I guess. So I feel like this should work, but it doesn't. How do I debug this? How do I debug this? And how do I explain what I'm doing here in a better way so that I understand it myself better? Is there any information about the macro hygiene in other places of how it's implemented? Hygienic macro systems in languages such as Scheme use a macro expansion process that preserves the lexical scoping of all identifiers and presents accidental capture. This property is called referential transparency. In cases where capture is desired, some systems allow the programmer to explicitly violate the hygiene mechanisms of the macro system. For example, schemes let syntax and define syntax. Macro creation systems are hygienic. So the following scheme implementation of my unless will have the defined behavior. My unless condition body, if not condition, begin body. Let not lambda xx my unless t and display new line. What is t? The hygienic microprocessor responsible for transforming the patterns into the output form detects symbol clashes and resolves them by temporarily changing the names of the symbols. The basic strategy is to identify bindings in the macro definition and replace those names with gensims, and to identify free variables in the macro definition. Make sure that those names are looked up in the scope of the macro definition instead of the scope where the macro was used, right? So this is the important part here, right? So that's why I am maintaining multiple different scopes. Where do I look up the names? Macro system had automatically enforced hygiene originated with scheme. Dun, 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 dun. Criticism. Hygienic macros offer safety and referential transparency at the expense of making intentional variable capture less straightforward. Many hygienic macro systems do offer escape hatches without compromising on the guarantees that hygiene provides. For instance, Tracant allows you to define syntax parameters, which allow you to selectively introduce bound variables. Greg. gives an example at fear of macros. Boom, 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 boom. All right, not a lot of information of how it's implemented. We would like need to actually look at the implementation. I think I can figure it out myself. I just need to debug what I have done. So specifically, where is the symbol X resolved, right? So maybe I'm doing the no std here, right? So this is the only place where I'm doing anything. So can I say here, so this over here is the place where I'm actually creating the new scope for the definition side, if it is not present yet. So how about we log here, entered definition side, hash definition side ID print result ID. And then whenever I inject the binding, oh, wait, hold on. When I inject the binding into the scopes, I inject the binding into all the scopes. Isn't that wrong? Well, right now I cannot find the symbol at all, so that makes no sense, right? Find binding is where am I trying to find it, right? So let's say this. Let's say this log info. Finding this in scope this ID print scope ID and label print label. Or is that not label? Find binding. This is just string. The label here. So let's see. I'm trying to find X in scope 1169. But then I never entered that scope. Wait, what? Maybe I need to do this when I enter, yeah, enter a child scope. Oh, wait a second. Injecting the binding. This creates a new scope. Like this. What am I looking for here? I feel like the inject binding is the issue. Inject binding is the thing which actually creates this mapping from a string to the actual binding, right? So that we can look it up later. What a certain name corresponds to. Isn't that still an unhygienic macro? So it's capturing dbg print. So yeah, the idea here is that dbg print should be available at the definition of the macro. That's another thing which is like different. So it is still hygienic because the dbg is a symbol that is available to us at the macro definition. It doesn't matter if the dbg is available at the macro instantiation point. Or at least that's how I want it to work, right? So it is captured in dbg print. But that is the hygienic stuff, actually, right? Then what's the difference between a macro and a function? Macro is creating code, function is just running code, right? Hello, Jankilatita. Well, I mean, macro is a function. Macro is a function that is returning the AST, so we can generate code. Function. Well, a lot of the things that, I mean, in this specific example, I guess, you wouldn't use a macro, right? Macros are like the last resort, usually. If you can do something without a macro, you should do it without a macro. But not everything is possible. For some things, you actually want code generation. Right? Bum, 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 bum. In Rust style, you would do std dbg print or something. Well, yeah, that's what I was talking about yesterday. In Rust, you have like create std dbg print, right? I guess if this was inside of the std or something, but I don't like that. We should instead just capture the symbols directly. I think, right? So the only difference is what is that, yeah, like we need to generate code. Functions allow you to do a lot of things, but not everything. Good question, though. Because like in theory, when we write a derive macro, do we need to do it with code generation, or do we just invoke a function and the function like body should be able to add the implementations of the trait, right? Because that function just needs to be run at compile time, because implementing a trait is just another like thing that the interpreter can interpret, right? So why do we need to generate it instead of just evaluate it instead of a function, right? If we have something like this, we have a function derive, like derive my trait, and the argument to this function would be like an actual type, so which is a type, right? And in order to derive this, we just say implement t as my trait as something, and over here we actually do the implementation, right? So like, why does yeah, I guess it could work without the code generation actually, right? And with normal functions. So I just call this function with the type, and then we like have some type inspection APIs, right? So we figure out what fields this type has, and then we do all of the things. Yes. So the difference, there is still a difference though, right? I guess this is more similar to maybe like the way Haskell's generic driving works then. Maybe, or maybe not. Because like it means that I will compile, like, let's actually write this out. Maybe. So I will eventually have some form of deriving, derive ks. Let's see here. So I will have my trait, which is a type self, and let's say like foo is I don't know, self into self, right? I don't know. Yeah, this into self. How about that? So then I want to, so like normally, for example, you do something like implement int32 as my trait, as this thing where foo is, let's just return 0 here, right? Something like this is what you do. But then we want to like derive it for all of the different types. So we want to have a function derive my trait, which has a type t, which is a type, and this just has the implementation inside. This might be is not working right now, like t as my trait, right? The only issue though, that this number literally is inferred as t, right? So we cannot do this right now, because we need this to be type checked properly. I guess in a language like Zig though, where type checking is only done when you actually call the function, right? So we know what this type actually is. We know the concrete type at compile time in Zig. So this is how going to actually type check, I think, right? Is how Zig works. But we are actually compiling this once, so we need to make sure that this 0 is of a, like, this must be an integer type or a number type, right? But t is a type variable, so this doesn't compile here. But ideally, we can also say, I guess, like, basically if t is equal to int32, then we implement it as 0. So inside of this, if we know that t is int32, my type system does not know that yet, though. Right? But it could. And then we do that. And if I wanted to, like, do some sort of the type inspection, right? So Maybe like it should not even be like deriving my trait. Like in general, the code generation. It's not even about the traits yet, right? Can we just have the function, which is like default value? So like, let's say we have a function which, given the type, it needs to give me the default value of this type, right? Can you write something like this in like Zig easily? So you will say that if t is int32, then you return 0, right? But otherwise, you want to like figure out the fields, right? So there is a type info t or something similar. So type info is giving me like, this looks dependent. I mean, yes, this is dependent indeed. This is dependent, which is why it should be like a generic, because I only support the generics as my dependent things. So type info would be a thing which is a type. So like how do we do the type inspection in general, right? So type info is just giving me the type reflection, right? So it is either an int32 or it is, let's say it is like a tuple with certain fields, right? With list of a field, right? And then field is a thing which has a name and has the type, which is another type info, right? And this is going to be like my thing, which is going to be reflection, right? These types are recursive, so this must be like a module. This looks like a rewrite. No, this is what I want to have eventually anyway. But since you asked, do we even need macros? Hold on, where's the error? There's a syntax error somewhere. I don't see it. Where's my parser error? I'm supposed to see the parser errors somewhere. It's at the top. Unexpected list. Oh, over here. Oh, yeah, because we need parentheses here now. Yeah, that's right. That's right. Okay, yes. So we have this. So let's say that we represent our type, something like this. So we are going to actually... so reflection should basically have a function get type info, right? Get info. Get info should be a function based on the type t type, and this should return type info, right? So this is like some native implementation, I guess. So over here then we are going to match reflection get info t, right? And this is all that this type can be then. So if the type is an int, then we actually return a 0. And then if the type is as a tuple with fields, then we would need to like to have some way to construct a type. Right? So we would need to be able, so yeah, we would need to be able to construct the value of type t. Like, yeah, how do we do it without code generation? How does this look in Zig, actually? I'm wondering now. I don't think I've went this far with Zig's comp time. So you can have field, right? Perform field access at by a compile time string. So you can get the field of this. Yes. What I want to, like, can you construct a struct if you like this is accessing a field, right? But how do you construct this point at compile time? We're given strings as like compile time strings of the fields. Should be possible, right? Or do they not expose something like that? They have type and they have type info. The function is the inverse of the type info. I see. Use type. Type returns type. No, this gives me the type, not the value of this type, right? I want to construct a value of this type. Can you? As t0. No, for the 0 it's okay, right? But how do we do this for the for a struct with fields? Right? I want like, so we have a struct point, and I want at compile time, if I have a compile time like a list of strings x and y, and like whatever, like their values, right? How do I construct? You know, like I want to create what I'm trying to write here is a generic function that does the default value of type t, right? How should this work? Oh, you just do field x. Oh, yeah, because you create the new struct which is not initialized, and then you just initialize it field by field. That actually makes sense, right? You create a new not initialized thing, and then you initialize them one by one. Because the Zig is basically C. So there is no way to like construct it fully immediately. Can you not construct the point? You should be able to, right? In Zig, just similar to C. Since your tuples are structural, isn't your value instance just the tuple with the correct shape? They're not exactly structural, but like, yeah. There's also naming involved, which is optional. We have both structural and non-structural tuples. There are helpers in stdmem, like zeros and zero init. Yeah, but we want to have the uninitialized in this case, right? So you basically return the value by doing like initialization one by one, which means that you need to have like uninitialized t, right? Something like this. So let mut result is this, and then you say like, and then you like say for field in fields, you like do something and then you return the result, and you say like result and like whatever you say like field, right, of a result and field name is equal to, I guess, default value of a field type, right? Something like this is what you would write in Zig, I'm assuming. Yeah, I was more wondering, like, because this gives me no guarantees that all of the fields are initialized. I don't have the way to do uninitialized yet, so I was trying to have a kind of a built-in which initializes all the fields at once instead, I guess, which would be something like like construct. So I want to construct a type by giving it the similar to like type info, we give it like the value info, I guess, or something. Maybe, I don't know. That's some ugly syntax. What exactly is ugly here? Your language is not powerful enough to leave things uninitialized. I don't have it yet. Also, like, so Zig doesn't have a RAI, I guess. So if you were trying to do something like this in a language with RAI, right? When you assign the field to a new value, you are supposed to drop the previous value, but this is uninitialized, so you're supposed to like not do that because this is initialized. So you're supposed to just do like pointer right, and you know, like something like this, you know, similar to how you would do it in Rust. Already in love with type equal to underscore. Underscore means that this is like just a placeholder in this specific place. Placeholders are usually used for inference, but in this case I just didn't write the implementation because this is supposed to be something like native get reflection get info, I guess, because it's supposed to be implemented in the interpreter, which is ran at compile time, right? But it's not implemented yet. So here's the issue with this. Oh, or is it not? Actually, it's not the issue, right? Because this is going to be evaluated at compile time anyway. So it like doesn't matter. Yeah. All right, but we're like looking into the different thing. I still need to. I still want to fix my macro hygiene, even if I am not going to use the macro hygiene, and we're going to do it like this way. We still sometimes want the macros, right? Macro is like if we cannot do it the other way, there is always a macro that we can use, right? To generate code is the idea. Have you gotten inspiration here, fish? Oh, so you were like joking when you said that you liked the syntax? All right. I see. All of the different kinds of fishes. Nice. What exactly resembles a fish here? There's no... I don't know. All right, let's go back to the macros. But this is a something to think about here. I'm just imagining that we're going to do similar to this, but we're going to generate code instead. That was my original intention. So we will still have the type info and the reflection, but instead of having this as a function, I want to generate the code. There's a do missing here. So we would have like syntax field Could not find field in scope. Oh yeah, and this is like the same thing. Because we cannot do a for. Alright. Yeah, we will come back to this later. Back to the macro hygiene. Okay. Can you do a for loop with just a function is the idea then, right? Yeah, actually, hold on. This is the example of why we need macros and not just functions, right? How else do you implement the for loop if it's not like a language native? Because this over here is a pattern. This is not like a value that we already have. So I'm not referring to X, which is already available in this scope. I am going to create this thing inside. So how do you do this as a function and not as a macro? This is like a fake loop, which iterates over the tuple fields. Fields X and field Y. What if you create a special scope that doesn't capture runtime variables? Something like a Rust function, and a macro always spawns that scope? Well, I mean, I want to do this exactly like that, right? So we have two different scopes. We have runtime scopes and we have compile time scopes. I call them compiler scope and interpreter scope, respectively, right? But we do have an interpreter ran at the run at compile time. So we already had before two separate scopes. One of them is the scope, which is a compiler scope, which is just a lexical scope, which we use for resolving the symbols, and another one is the one that actually holds the values. So I guess I already do that, right? And the only difference is that, like, the lexical scope, the compiler scope, is basically giving me the reference to the runtime value right now. But in case of like in this example, right, we do dbg print. You say that we capture this, right? Dbg should just be a constant and not a reference to the runtime value for this to be captured properly. So lexical scope, when we look up a symbol, like what dbg means, if this is available to us at compile time, then we should just use that instead of referencing the runtime value. But right now I don't do that. But it should be done easily. We first need to like fix the name resolution though. Here. All right. It's been an hour and a half and I did not do anything. Let us know what you need help. We'll send some troops to try to fetch you back to reality. I see impulse index and you see fake loops over patterns. Okay, so there is some bug, and I need to like understand how to debug it. Shit. X is not found in the scope. So I want to like explicitly log all the scopes that I create, right? That's what we want. That's what we want. So I was doing some this, right? Info finding in this specific scope. I want to like, whenever I create a scope, I want to know what is its parent scope. Entered dev site info. Maybe let's just do this over here, scope enter, right? We're going to say that this is ID, so say let ID be the ID gen, and then I do log entered scope, this, let's say parent into child, like this. So we'll do ID print parent ID, ID print ID. This way I should be able to see all of the scopes that I created, right? So we are trying to find X in scope 1169. So the question is, 1169 is the parent of 1169 is 1164, and I entered the dev site here. Okay, it would be nice to know why did I try to enter the dev site. Which means that I want the span here, I guess. Or is it because I was injecting the bindings? Let's see where this function is used, right? It's used in just in two places. One of them is over here when I was doing that. Okay, sure. Let's give it the span as the argument. Span at span print span. So in this case, since I'm injecting the binding, span is going to be binding. I do have binding span, whatever that means. This is where the binding was created, right? I kind of want over here then to log also injecting into dev site binding, print binding. Okay, so we are trying to look at 1169, 1164 is we are entering this over here. Okay, so this means that we have this over here is the body of the this is the body of the loop, right? This is the last thing that we are entering, because yeah, I guess the body is this over here, right? So the body over here is this. Before that, I was supposed to also enter the same definition site before. Enter definition site 1164. Okay, but 1164 is a scope that was created with the parent scope being 377. Okay. But over here... Oh, over here we say let x. This also was a different definition site. I don't care about this one though. Okay, but then over here I entered that. Injecting into dev site x. Oh, like one of them is this x and one of them is the other x, right? So we are injecting here and then we're injecting here. This can be commented out, so we only see one x being injected. Now we are in scope 1124. 1124, 1119. 1119 is over here. And this is a new scope, so that's the issue, right? And then there is a 377. 377. But when I was injecting X... Wait, why am I injecting twice, by the way? Why am I injecting X twice? Maybe that's the bug. Injection into definition site this X, right? So this one is injected because this is a pattern. It's used over here. But then we also inject into dev site X. Oh, wait. What? This is the same one. So I create multiple different scopes? Why? Finding value in scope 1075. So value is over here. Oh, wait, hold on. I'm doing a custom let. If I do a normal let, not a custom let. Oh, wait, it makes sense. I do twice because we have a custom let and a normal let. Let's comment this out. That makes sense why we see it twice. Okay, so now we are trying to find in 1048, 1043. 1043 is entered over here. But then when I was injecting, I only injected it once now. And okay. So here's the issue, right? I created a new scope whenever I was compiling this let pattern be value. injecting into definition site X over here. Like I'm looking in a different scope. This is the buggy function, I'm pretty sure. So we are doing the enter def site first, and then I inject the binding. So I entered def site, a result ID, right? Yes. Wait a second. That's right, because def site ID should be like this def site ID. Or not. Wait, yeah, I mean, yes, this is actually it. Okay, entered definition site. ID print. So definition site is def site ID, right? But I entered, and now the definition site for this is the result ID. It's a little like this, maybe. So X in scope, finding X in scope. Hold on. I want to also print the definition site ID of the binding when I'm finding it here. So definition site is this. Over here, we'll do another log. Finding this in definition site. So this is going to be scopes definition site ID. And this is going to be option print because, yeah, more information is needed. Okay, so I'm trying to find the definition site of X is 377, right? So this code. So 377 is this like scope, the top scope that we are processing here, I guess. But the scope that corresponds to that definition site is 1048, right? 1048. But I was just entering it, which means that it does not have any bindings. But we might have the binding in the parent, 1043. When I was injecting into the definition site, we entered the scope, entered the definition site, entered scope, 1030. Like, I want to know into which scope the thing was actually injected. I guess. Over here. Over here. Right? ID is this. Log info. Injected. Oh, and this is like a new scope, by the way. This is a new scope. This is weird code too, a little bit. Injected this. Into that. Parent is id option print id print parent scope parent option map function scope id. Okay, I'm finding it in 1048. Definition site 377. 1048 is this thing with a parent of 1043. 1043 is over here because I entered this, and this is the direct child of 1043, which is wrong, because I previously was entering this definition site over here when I was injecting the definition site. So I injected X into into 10 different scopes apparently. Um 1018 is the important one, I think. 1018, I entered the definition site and I put this thing here. And so 1035. But then over here, when I was entering the scope and I'm entering the definition site, okay, so it means that I lose the information about the definition site. I lose track of it. Why am I losing track of it? When I'm compiling this, I have compiled this. We have a pattern here. I have injected the patterns, right? I have injected X over here, and when I'm compiling this, I should have all of that to be available to me. So I should have not created a new scope, but I am creating a new scope and I'm looking in this newly created scope for some reason. So the problem is just enter the definition site. When I'm injecting the binding, injecting into the definition site. Oh, but it's the binding definition site, right? Yeah, let's definition site for this. I want to do ID print binding definition site ID, right? Just to make sure, because I'm injecting to the definition site for X. Oh wait, the definition site for X is 1018. Binding definition site ID. I think this is not correct. Maybe when I create the binding then? Hold on. When I compile the pattern, and this is the identifier, the definition site is the current definition site. Maybe this is wrong? Because this should actually be the definition site of the current AST that I'm compiling. This one is optional, right? But we basically say that it is the definition site, or this, or the current definition site, if we don't have the definition site dedicated for this AST. But this was supposed to be entered anyway, right? Definition site. Or is the definition site because I was entering it? Hold on a second. So bindings are also holding a definition site, but this is the site that I entered there, which is different. Yeah, okay, I actually kind of get it. I should instead get my definition site ID here. I can get this definition site. Okay, fine. Definition site, option, unwrap or else. This. That's probably also not correct though, but is it going to work? But it worked. Hold on a second. This actually worked. First try, easy. Okay, it's a little bit of a mess though. Like, in order to do this properly, I need to understand it myself. Seems like it is working though. Right? So here's our test. And this x corresponds to this x. Okay, nice. If I say let x be 1, 2, 3 here, this x is not... Oh, wait, now this x is equal to this x, actually. Hold on a second. This is wrong. That's not what it should be. No! Wait. But it is still printing it correctly? It's just go to the definition is wrong? What? That makes no sense. Restart language server. The LSP is going to that definition, which is incorrect. But the output is correct. Finding X in scope 1047 in definition site 377. Injecting into the definition site for this. 1030. Is there another injecting the loop body? I want to like see another X, right? Well, this X. Yeah, so this X, the definition site here is 1051. X is 377, right? So we do see the different definition sites for this X and this X. When I'm finding X, I'm finding it in definition 377, which means that I'm trying to find it in scope 1092. Scope 1092 has the parent of 1077. Is this thing with the parent being 377, and this is the thing that I injected when I was injecting this X, which is the second X, which means that it's wrong. But why was it done like this? Because we are injecting into the definition site for X, so the definition site of this is 1074. But I injected it into 7. Oh, wait. No, this makes sense. This makes sense. This weird stuff, right? Like, why am I injecting my symbols into all the scopes? I only need to inject it into one scope, right? You see this over here. Scopes, map, inject, binding. I'm literally injecting it into every single scope. But I should not do that. I should instead inject into a single scope. So we're going to once again match binding hygiene, and if it is call site, then we are only going to modify the call site, and it's going to be call scopes call site inject binding. So this got like scopes with, right? And if it is a definition site, then I'm going to only modify the definition sites. Which is going to be scopes, definition sites. I'm going to need to update only the actual definition site that I care about. Oh, I mean, I entered the definition site here. I entered the definition site here, which means that it is my current definition site, by the way, which is maybe not correct. But I should update. So this is ID map, and to update the definition site, so which is binding definition site ID. And then we have this thing, function, scope, sum, scope option get, scope inject binding, because this one is supposed to actually be there already. Is this going to be correct now? And now it cannot find dbg in scope, actually. Hold on. Over here. Why? Finding dbg in scope 591. Parent is 576. 576 parent is 422. dbg 365. We want to find the 365 here, right? 422 is from 390. 390 is from 375. But I need 365. What? Why is this so difficult? Uh, 375 is the parent. The parent of that is 111, which is wrong. Right. What is this? Inject binding. Def site ID is not used anymore. Probably right. Hello, Regicide. So it could find AST, by the way, over here, right? But it could not find the DBG over here, right? Let's say lat underscore AST to be equal to underscore, because this is kind of like similar. I want to find the AST symbol here. But it actually cannot find it. Okay. Can I? So this is my macro. Okay. But if I try to do it over here, maybe, or is it like because this is inside of a macro actually? Yes, I cannot find this one inside of a macro. Okay. So but it could be found over here. Because this could not. So I'm trying to find AST in the definition side 422. I entered this 422 598. Yes. That kind of makes sense. So like this scope over here is 422, right? Is it? Oh, wait. Well, I mean, in any case, we have the AST defined earlier. Okay, but this AST is in one place and this AST is in another place. Okay. Yeah, because this is outside of a macro and this is inside of a macro. Which kind of is different, right? The problem is that over here, when I was constructing this thing, I like this also had the definition site defined as the compiler scope when I was parsing this. So I was injecting into the thing corresponding to this thing, but I should not. I feel like maybe what is missing here is my bindings. Their definition sites should actually be optional, right? Because that means that they are just the top level ones. And I should not enter anything, right? So whenever I find binding, I'm going to say none here. Inject binding def site ID. Yeah, so I'm entering the definition site only if it's needed, right? Yeah, so I'm going to match binding def site with some def site, then we do this. But if it is none, then we just don't do anything. Let def site be match binding hygiene call site none def site match binding def site, then we just do binding def site, right? Like this. Okay, so scopes is we're going to now match the def site with some def site, then we do this, otherwise it's just the scopes. And over here, once again, we're going to match def site with none or some def site ID. Okay. So the definition side when I'm compiling this tuple, let's do none here. So I just do def site here now. No optional things. Alright, now it just says that it cannot find X in scope, but DBG was found successfully. It cannot find this X, which is defined over here directly. The compiler cannot find this. So into which scope is this is the definition side of this specific AST, but this one is none actually. I think. So we only store the definition side for the top level AST. So this is all wrong now. This is all wrong now. I feel like this definition side is also wrong. The definition side should be like scopes, definition side, ID, right? Which is the ID option. Which means that I want this to be just ID option. Maybe. But this is not, no, this is not doable, really. Undo. Undo that. And keep track of this actual thing. I need to have state scopes def site, like the actual definition site. Yeah. So we are, but I only store the definition site ID here. But I should actually store the definition site itself, which is going to be a scope T option. Right, so definition site is none, like the current definition site. Right, definition site is the old one here. When I'm doing the map, enter, we do that. Enter definition site is this. Definition site is some definition site. Definition site of the scopes. Match scopes definition site with some definition site. Find def site ID. So whenever I'm trying to find binding, the scope in which I'm trying to find it, definition site. Wait, why am I trying to find it in the current one? What? Def site of the scopes. Oh yes, find bind. Yeah, okay. No. This makes sense. So did it work now? It compiled. X in macrodef, X global is seeming to be correct. But the last thing is not, because it's printing 1, 2, 3, so it resolves it incorrectly again. No! How long until I give up and just like do the non-hygienic macros? we have gone very far without them. I'm also wondering if my previous like, because I thought that I had that in my previous Rust version, right? So I have the previous version of the language. This was originally in Rust, and I thought that I had the macro hygiene there. So right now this thing resolves to this X, which is wrong. All old series software is running on C after all. Yeah, and C does not have hygienic macros, which means that you can write code without those for sure. So finding X in definition side 435 with scope 1020, I was injecting the X, this one X was injected into the definition side. Oh wait, the definition side here is also 345. That is wrong. That is wrong. And this one was injected into the 345, and this one was also injected into the 345, which is different. So why is that? Why is that? Why is that? I'm pretty sure I actually know the answer. Let's take a look here. Though this is my old version of the language written in Rust. There is macro hygiene example here even. Right? So what do we have here? We have let hello is macro, which just returns let hello be equal to hello, and then we print hello. Okay, hello, hi, named. Cast examples macro hygiene. Target debug cast. Cargo build. Is this not in target debug? Oh, it's called cast bin now? Okay, I see. Well, anyway, we just do cargo run examples macro hygiene, I guess. Okay. Named. Okay. But maybe this example is just too simple because I never had the loops, right? Or whatever. Yeah. Let's try something if that works. So we say const loop macro. It's macro name ast. This returns something like, you know, I want to create a new scope here, and inside of this scope I want to say that let's name is inside macro, and then we print name loop macro hello. You know, I print the hello here, right? So this is supposed to print hi, but it printed named. Oh, because we did a let named hello. No, this actually is correct. Okay, but now if I try to print name here, it is going to print inside macro. Wait, it was working previously? This is a little bit different though, right? This is a little bit different. I want to actually like do the loop syntax, right? To test if it was working. Syntax, loop syntax for pattern in value to body. And then we like implement syntax, loop syntax, b loop macro. That's how I was doing it before. So we need to have like the same names here now. Pattern is AST, value is AST, and body is AST, right? So we do the same stuff where loop body is a function value into let pattern be value body, and I'll say loop body let value be value body value x loop body value y, and we try to do this for x in x is one is hello, y is world, print x, line 34, expected quote go to end the file. Okay, yeah, because I did not close this. That's right. Different binding power. Is it because I already have a 4? It should be 3, right? Pattern is in connect structure. Different unnamed count 30. Oh, it should be named, right? Dot value and dot body. Okay. Expected string, result is string. Because when I print, I need to do like reference when printing. Okay, hello world. Wait, hold on. This actually works. Or does it? Let x be like yo yo yo. Wait, it actually worked. And I'm doing something a little different now. It seems like it works here. It seems like it works. Okay, let's look at the code then. What am I doing differently? I'm doing something completely differently this time. I'm pretty sure. So I want this over here, Kast scopes compiler lookup, right? So we have hygiene here, and we have a name which is a string, right? This is when I'm looking up the identifier. So the AST is storing just the hygiene inside. And hygiene is just the definition side only. Oh, and there is the definition side, which is an optional reference to the compiler scope, just like I'm doing right now. Right? Okay. That is something I'm doing right now, but the lookup is probably done completely differently, right? We are saying that if the hygiene is definition side, then we look up the name self0, which is my current scope. So the compiler scope has a reference to the actual scope. There's only a single scope that I maintain, not 1,000 of them. But this probably means that, like, this definition site is used somewhere. So when I'm constructing it, when I'm quoting the AST, this is the same thing, new temporary. Initialize AST. So by default, all of the definition sites are none. When I'm compiling the identifier pattern, I just don't care about that. We have a thing which is called set definition site. Oh, this is mutating the AST to change the definition site to be the current the current compiler scope. So in the scopes, we maintain the compiler and interpreter scope. Okay. That's the same as what I was doing previously. So it basically says that when I'm compiling the AST, and if the AST has the definition site, then I am changing my current scope. So that I can enter the definition site here. So the compiler scope just becomes the definition site. I feel like this is wrong, actually. Doesn't this mean... Hold on, doesn't this mean that if I go to the macro hygiene example, right? And if I try to print X here, then it's going to work. No, X is not found there. Okay, good. Wait. But it's not found when evaluating. At compile time, it was found. So it's kind of wrong still, because the error happens at runtime, not at compile time. Right? Like over here, it's evaluating binding X. So like binding X is this binding, which is defined over here at line 32, 5 to 6. So it's trying to find this one over here. So it resolves the symbol actually incorrectly still. So yeah. Even though it kind of works, it still is not correct. My old implementation either. Okay. So what's interesting is that this first example is still running correctly. Right? So it still says that this one is X in macro definition and this one is global. But in this case, it's not the case. Because... Okay, why? Why? Because, okay, I think I actually know. Because over here, when I was injecting this binding, I said enter the scope. I said enter the scope. Over here, when I was injecting the bindings, inject binding in the scopes, right? Injecting the binding resulted in me entering the definition site, but I should continue compiling in the old definition site. So it's like it's changing the thing, which is wrong, right? So let's say that so yeah, I want to say like old definition site is scopes definition site. And I want over here, I say call site is this, def sites is scopes def sites, and def site is old def site. In this case, call site is scopes call site. Def site is this, and def site is still the old def site. Let's see if this makes this work. Please. Okay, first try. Easy. Okay. It seems like it's actually working. Now let's try to do the cast. Okay. The standard library compiled. So maybe everything is working actually. We can forget about this madness because like I will probably not be able to understand this code myself. But I mean I kind of understand it, but only like I need to be able to understand it better. But we can forget about this issue if this works now, right? std io print hello world. Okay, let's the ultimate test of course is the advent of code. So we do like cast test the advent of code solutions. It didn't work immediately. Okay, why? Because std is not found. Okay, hold on. This actually makes sense. This actually makes sense now. Because this is a because this now is a hygienic macro, right? This is now a hygienic macro. My example with the hygiene was using the no std, right? But if we go to the test and I actually use the standard library and I say something like for x in 0 to 10 to dbg print x, right? Something like this. Then this doesn't work because the for loop, or the for loop is doing that. So in this case, the std is trying to be found. So like std is resolved. std is resolved to this thing. We say so std, like, because this macro is defined inside of the standard library itself, in order to use this syntax inside of the standard library, we are doing this. This is a constant, right? And now we are referring to this symbol, but this symbol is a different symbol than the symbol that is the std in the actual like code. So one of the ways to do this is to make this no hygiene. But I obviously don't want to do that, right? But this is going to now complain about the other std, right? But that std works actually. Okay, but how to make this work? In order to make this work, once again, since this, like, it basically should resolve not to a symbol, so right now it resolves to a binding, which is a reference to a runtime variable. But it should instead be evaluated to a constant directly. I kind of want to commit everything that I did. Can I like say that hygienic macros whip? Yeah, whatever. Let's just do that. Yeah, so like anything that like is used, it will say that std is not found. That makes sense. So here's the idea. Here's my compiler scope. Compiler scope just has the bindings, right? So it is a map from a string into the binding, which is a reference to a runtime value. When we do evaluation at compile time, so like constants, which are the so constants are just the values in the interpreter that is used at compile time. But I feel like over here, when we're resolving a symbol, we should directly know if it's a runtime value or if it is a compile time known constant. In which case, it should not even be a binding anymore. But it should be like a value directly, right? Or a place of the constant. These bindings are also used to like figure out the type of the the type of the module. So in this case, const. So const is actually compiled into, so it's evaluating this thing at compile time. Then it basically converts this into like like, let's go to test. If I see const x is equal to something, then this actually is converted into just let x be something, but then it also, before doing this, it evaluates let x be something at compile time. So it's doing this, and then it also has the runtime thing like this. Right now, which actually might be a bad idea that I'm doing it. But it also means that when I'm compiling, basically, if I have a const, right, when I'm seeing later in code like x, this is compiled down into a reference to the runtime variable, not the reference to the not the constant that is inlined, right? Which actually is bad for performance, maybe, right? Because we could just store the constant directly here. That would make more sense. So we want to do that. All right. So yeah. So it's not bindings, right? What do I call this? Then this thing is not used in a lot of places, so it should not take that long time. So these are like compile time known. I guess I can call them like symbols, or it's like. I don't know what to call it. So it's a map from a string, which is when we're performing the symbol lookup, we're looking it up and we get a reference to the runtime value right now, but we should get a reference to the constant directly instead, right? Find symbols. Find symbols. So symbols is and this is, so this over here is not a binding anymore. This is going to be compiler scope symbol, maybe values. I don't know. It's not a value. It's a thing, which is either a constant or a reference to a runtime value. What do I call a thing which is either a constant or a reference to a runtime value? Binding, making compiler. Call it a value and move on. LLVM uses operand. I don't like operand. LLVM operand. What do they actually call operands? Operand bundle. But what is an operand? Yeah, is there like a thing where like they call something Well, I mean, so yeah, like there should be something similar, right, in LLVM where you assign like you have something which can be either a constant or a runtime variable, right? I just right now I'm treating everything as a runtime variable, basically. I mean, there are just constants, right? Constant expressions. Like your expression can be a constant, or it can be a reference to a runtime value, right? So, which means that it is an expression. But in terms of like the compiler scope, when I'm resolving the symbol, it cannot be like all of the different expressions, but only these two things. It's either a constant or a runtime value. Run would mean any operand to an R instruction. Well, I mean, but operand is basically, I mean, operand is just a value, right? But a value can come from a constant or from a runtime value. So maybe operand is the correct name, actually. It's any operand to the instruction. So your instructions, they take operands, and operand can be a reference to a runtime value. I call these bindings. Maybe they call them something else. Or it can be a constant. Operand just makes me think operand of what? Yeah, it's like makes me, yeah, I don't kind of like the name either, but like, for example, when you are trying to call a function, calling a function is an IR instruction too, right? Where we have two operands, which is the function itself and the argument to the function, right? So those two are operands. Although I like when I think about operands, I think about math, right? But it's more general than that, I guess. So the function can be a constant, and the arguments to the function might be a constant. So I don't know. It's kind of, yeah, maybe. Any other names that you would prefer to this? Operand. The first place where they say the word operand is over here, before it was defined. They are not defining what operand means, right? They are using operand bundles before the operand is defined. A link to the definition of the operand in LLVM. It also says that it uses like assemblers and IRs, right? Maybe like some other compilers, you know? What do other compilers call it? So it could be a literal value or a runtime address where you look for the value. It just sounds like a variable. The problem is that like it's super general. Well, yeah, it could be a literal. It's not necessarily a literal value, because constant is not necessarily a literal, right? It's something that is evaluated at compile time. Literal is just like the simple like constant, I guess. But the constants could be more complex. Like the standard library itself is a constant. You know? Resolvable. Binding or constant. No serious compiler use that. Okay, crane lift uses just value. We almost called it node, but then they called it value later. IR value, IR expression. Rust uses operand too. Just make up a name. Compiler scope thing. Const or binding. we don't need to like come up with a name. We just call it const or binding, right? And this is like the so this and what's this? I call this symbols, but I could call it something else. Lookup table or something. So when I look up by a string, I get either a constant or a binding, right? Don't need to come up with a name. Just do this. And const or binding is basically the const of value or binding of a binding. That's all. Okay, now we just fix the things. So this is called now lookup table. All right, so over here we say find binding opt, right? But now when we are finding, let's just call it find opt, right? And this will return a const or binding, right? Find opt. Lookup table. Does Kast have functors? What's a functor? Depends on the definition of the functor, I guess. As in a camel. I don't make it like so. Basically, the idea, yes, not Haskell. Yes, so like something like OCaml. Yes, the idea is that so like in OCaml modules are like a very special language feature, but I just say that a module is just a regular value. So a functor in OCaml is special because modules are special. So for me, a functor would just be a function that returns a value. That's all. So you're supposed to, and so like module signatures are just regular types, but it is a little bit different because module signatures contain like types, right? Which and then we like use those types to annotate other fields, which basically means that OCaml's module signatures are dependent types, you know? So that's like the plan for the future. I don't want it to be any special language feature. We just let's do a simple like example, right? So in OCaml you write something like this, you know, module like foo, which has a signature, you know, type t, and print, which is t into unit, for example, right? And this is going to be equal to struct where type t is I don't know, an int, right? And print x is print int x, right? Something like this. So the idea is that we just do this. We just do let foo, which has the type t is type, and print is t into unit, and this is just going to be equal to the thing where t is int and print is you know, x into print int 32x, right? Something like this, right? But this is not working right now. It says t is not found in the scope because this is a dependent type. We are using the field of this type to specify the type of the other thing, right? But that's what I want it to work like in the future. But yeah. So right now I can do this, but I can do this without specifying the types, I guess, right? So I have this special syntax, which is called module, which is just constructing this value for me, but I cannot really name the type currently, I guess, like in the general sense. And yeah, so something, you know. But it should be possible at some point to make functions that return packages out of other packages, yes. Because packages are just values. Everything is a value. Is it also possible to make Haskell-like type class system with Kast? Yeah, I do have it too. I already have the monad example too. There is a little bit of the inference that is missing for the higher kind of types in general. But yeah, so we also treat like type classes as types and type class instances as values. So so a monad is this thing, right? Which has the higher kind of type as its argument. And this is the instance, and we implement like stuff. Yeah, it's possible, yes. Although there are some limitations to the current implementation. I don't do some... I cannot have the generic implementations right now, which I should. Yeah, there are definitely a lot of things that I am still to do. But there are a lot of things possible already. And I think ideally, in the end, the type class system is going to be more like the implicit thing. Like, you know, Camel, there is a proposal for modular implicits, which they would use to like mimic the type class system. Right now, you can mimic it with modules, but like it's very verbose. So you instead do it with implicits, and there are other languages that are also doing that. The anti-language is one of the examples, where you have traits as types, and trait instances are just implicit values that are passed along with your functions. I'm not sure if the current documentation actually like reflects that. Maybe not. Some of this stuff is also outdated, but yeah, they are doing something like that. There's something similar to how Scala does it, I guess, where your trait implementations are just passed as implicit arguments to your functions, which means that you don't have to have the global coherence, I think is the word, right, for your traits, where you only can have a single trait implementation for your type. So you can have a local trait implementation. To use instead of the something else, you know. I think in Haskell they just check the instances to be unique. I'm not sure how it works in Haskell, but I'm assuming that they are doing it once like the final program is compiled. In Rust, there is a thing that is called the orphan rules. So by doing this as a local thing, you don't need the orphan rules anymore. But right now I'm doing the global thing, and I'm not even checking, I think, for uniqueness, or maybe I am, but I'm doing only the simple type, so yeah, whatever. It's going to change the implementation of my traits. Alright, what is this? Label add reference. Binding label. Oh, wait, hold on. Yeah, I still want to be able to go to the definition, is the thing. Right? So right now, whenever I'm looking for the thing, I add a reference so that like the LSP can report. And in order to go to the definition, we also need to know this. So I guess const or like const or binding should still give me the like something, you know? So the constant at... Oh, wait, maybe like this should be called compile time value, right? So, yeah. Well, I mean, which is a value, actually. That's all that it is. Shit. Wait, and I have the interpreter. Hold on, maybe I can do it without doing anything like this? Because, so, the compiler actually has two scopes. We have the compiler scope, which stores the references to the bindings, and then we have the actual values in the interpreter scope, which is being used at compile time. This is how we can know if the value actually exists there. So maybe I don't do this. Undo. But how do I... yeah, I guess the question is, how do we compile the binding, right? So we, over here, Kast compiler. When I want to have when I'm trying to compile a simple token, so if we are trying to compile a place expression, I see that we have an identifier, then we're compiling it to a binding. But we should compile it just to a constant in case this is already a constant, right? And the expression, this is just claiming this thing. Yeah, hold on. This is actually what I need to do. So we're trying to find the binding. Finding the binding, this is just binding, right? So binding is this. We found the binding, but now this binding might already be available to us as a value at compile time. So we're going to match state escapes interpreter. Scope interpreter scope find opt binding name. So I'm trying to find this in the interpreter, use that compile time to figure out if this is a constant. Wait, but oh, hold on. I cannot even do that. Because when I'm compiling this thing, the interpreter is already different than the interpreter that was used when I was compiling the standard library. So I actually need to do it directly in the compiler scope, I guess. Yeah. Another solution is that I could store the actual value like in the binding. You know? The other solution is that my bindings, they can store the value inside if it is a compile time value. Because I still know like all of these other things here, right? I'll go take a quick bathroom break. So, fine. Let's redo whatever I just did. So we have lookup table, which is compiler. I also call this like for the interpreter scope, we just have locals. Yeah. Yeah, actually, we should call this locals. You know, and this is going to be compiler local. And this is interpreter locals. That's maybe a good name. And compiler local is either a constant or a binding of binding. And in case it's a constant, I need to know the value of it. But I feel like I also, let's call this compiler const. Compiler const is a thing which has the value, but I will still have the binding. Should it even have the value, or should it have the place in which the constant lives? So we can have a reference to the constant value like that. I guess it really kind of like doesn't matter. But maybe let's do place. Similar to the interpreter local, it also has place, which is storing the actual value. Compiler const. Is there like a reason for me to... Places are normally used because we can mutate the values inside of them. But this thing should kind of not be. So maybe I want a value instead directly. Let's do place for now. Maybe I will change later. Lookup table. No, locals. Locals. Okay, so in this case, the local is a local. Right? So find opt, this should find the compiler local, right? So I will return local. And then we are going to match local with const place and binding, or binding. Then I want to add the reference to that binding there, right? Find opt. So this should be like just find. This is going to be a compiler local. So this is going, so if it could not find it in scope, then we will default to a runtime value and not to a compile time value, right? Or should we, if it is not found, or should I like have a constant? Let's have binding. This is not binding. This is compiler local. Let's just do the binding for now. Doesn't matter much. This is just for the error resilience, so that the LSP can do more work. Inject binding. So inject binding. So binding is a reference to the runtime value. So we do scope locals. We add binding name, and this must be like an actual binding now. Right? Locals. And if it's not recursive, well, we need to add local, basically here. Yeah. How about we do this? Let add local is a compiler local. Can I do like type local? It's types compiler local. Yeah, how about that? Bum, 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 bum. So instead of inject binding, we will have add local scope, and this is all of that. So local name. Let name be match function local scope. Name is match local if it is const. Binding place ignored or binding and return binding name, right? This. And then we are going to do all of these things here. So I'm going to add not the binding, but I'm adding a local. And this is name. Where is the syntax issue? Over here. So when I inject binding, no, let's just not do the inject binding at all. And this is just going to be local. Injected into this. Just print name here. Okay, over here, not inject binding, but also just add local. Let's just call it add. Why do I need to add local? Just call it add. Scope add. It's not the binding. This is local. Scope local. And this one still has the binding hygiene, right? Let hygiene is match local with const. I like. Hold on. Or binding. We do this in two places, right? I kind of just need a thing binding local. It's return binding, right? So there's going to be match local with const binding or binding. Yeah. Yeah, so this is going to be like let binding be local binding local, and then we just do that. And over here, let name, so this is just going to be local binding local name. It's my name. Okay, and over here when I'm adding the local, hello, OCaml, LSP, broken, again, nice. Okay, so we have a local. I want to find the definition set, so I'm matching the hygiene here. I don't have the binding. I mean, let's just have the binding here, whatever. Binding is scope local binding local. And I should be able to figure these things out. So, but we just add the local, not we don't add the binding. Right. Okay, and then bindings. And we can still have the bindings actually, right? Because we can have call site locals. We're going to map local into, we're going to map using scope local binding, right? Find binding. We don't do find binding, we just do find and return find. Okay. Now inject binding here. This is going to be called add local. So we're going to add, and add local should have the local, not the binding anymore, right? So local is state scope local. We are going to add the local, but if it's not only the compiler, which means that it should be able to be had in the interpreter, then we are doing it in the interpreter, and this is where we inject the binding, because this must be the binding, right? So in this case, binding is state scope binding local binding local. Okay. Inject pattern bindings. In this case, these are all going to be bindings for sure. So we're going to add local only compiler, and we're going to add local binding, right? Okay. Core syntax. Okay, everything is broken here, it seems. Unless... no, there's only one error, or a couple. So in this case, we have a compiler scope. State scope find binding, right? From scope is this. Oh, the scope in which we're finding in this. Yeah, so we have the value compiler scope. Okay, that makes sense. Yeah, so this also is potentially a constant, right? So yeah, this over here. So we have a local. So we're going to say find. We're going to say find like this, and then we need to have something like compiler local C state local. So this should give me a place expression, I think. And then to give it this span. And this is the local. So it's either a binding or a constant. And we're going to do the same in the other place. And then we add the data, object expression, object, because we have evaluated it. Right, yeah, okay. Compiler. Okay, let's see. So we have somewhere. I don't know. Let's see the bottom. So local span state local is this. So this is just like before. We're going to have a binding and we are going to init place expression. Right? But in this case, it's not a binding. So local is state scope local. We're going to actually match the local. And if it is a binding, then we're going to do that. But if it is a const, which has place. Oh, but okay, this is a place. Like my constants can only be evaluated into the values. So in this case, if it's a place, we don't care about the binding at all, right? And we just say place expression temporary expression. What is temp expression? Oh, I'm compiling it still. Oh, we just need a temporary expression to the constant, right? Where const is expression constant with a value init expression span state. But the value constant expression has ID. Why do I have IDs in my constant expressions? I think it's not even used. Unless the JavaScript transpiler is using it, it's not. Whatever. I'm just going to say that ID is idgen value, where value is interpreter. We need to read the place, right? Let's do this for now. Core syntax, tuple field. Yeah, so this is literally the same. We have a binding, but it's like, yeah, this is the place, and we're claiming it. I feel like maybe like I want to have two like local place expression and local expression. So like place expression evaluates to a place, expression evaluates to a value, right? In this case we have a value, in this case we have a binding, which is just a reference, so it must be a place expression anyway. I guess. So can I just say that if it's a place expression, then I would do this. But this over here is going to be a const. Like in this case, I'm just going to say this constant expression is just local expression, span state local. And in this case, if it's a binding, then we're going to instead say expression claim, local place expression, span state local, init expression. And in this case, we just return the constant like this. Okay. So in this case, I want an expression. So I'm just going to say, I'm going to find this thing and like claim whatever. We just say compiler local expression, right? Compiler local expression. State span. What's the span? Just span. State. So this is going to be compiler. Since this is a place expression for the dot syntax, right? Local place expression. Okay. If this find binding, if this is a type expression, okay, yeah, we just say this into, yeah, we just say that expression is this into compiler local expression. What is this now? Use dot star. All the bindings. Compiler inject binding. So when I'm using dot star, if I'm using something that is available to me at compile time, then I should like have the constant still there, right? Which means that I don't do the binding. There's a binding list. If this is a tuple, how do I get the binding? This is my binding. I'm creating a new binding, right? And then I actually, oh, but I actually evaluate it. I see. To make the things available to me at compile time. But now I cannot like really do that. Because I need to do that directly. Because we're just going to have the locals. And do I even need expression use dot star then? Because that is going to be resolved at compile time. Maybe I don't. Ideally though, I want this to be usable with runtime values too, but it's right now doesn't work with runtime values anyway. So So yeah, we are in any case we are evaluating this thing, right? Yeah, so I know that this is a thing. Yeah. So yeah, and I already have like the value, right? Here I know that this is a type tuple. Like, hold on. Yeah. We just need to have locals. We're going to just add local. Only compiler, but now it only needs to be done in the compiler actually, right? Like, why would I even need to emit the use.star? True. And I don't use the dot star, right? I literally compile this down to nothing, to a unit. Without this, but since I have evaluated this, used expression, we need to add expression, used expression. So I just need to figure out the locals, which is my value, but my value must be like a tuple here anyway. So I don't care about the type of it, I care about the value of it, right? So I'm going to match used value await inferred then, right? If it is a value tuple, then we're going to do something. Otherwise, if it's other, cannot use dot star value print used. Syntax error. Unclosed opening bracket. Where? Are you lying to me? There is no unclosed thing. Syntax error wildcard not expected. Okay, so we have a tuple. We say tuple. We just go for the named ones. Named. Hold on. We just do. Hold on. We just do. Yeah, we just do something like tuple. Tuple iterate. Member. Field. No, because there's no let. I see it now. Yeah. But I don't want it actually. We just do this, and then we do semicolon. Like that, yes. I'm just going to add local there directly when I'm iterating over this thing. So I need to create the binding. Right? I will need to create the binding anyway. For the binding, I need this symbol. Dun, 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 dun. type value tuple field. So I have a type tuple field which has the symbol inside there. Field type symbol. Type field symbol. But what's the name? And name is just a string, right? So this is going to be meshed on this. Okay. Yeah, so name in this case. Name, match member, index, I, int to string I, name, a label. Oh, we don't do this if the label is not there, right? Yeah. We're going to match field type field label with some label. And we do this. If it's none, then we don't do anything. Field type, field type. Okay, so this is my binding, and now this binding, and I potentially have also the actual value here. Well, I mean, I do have an actual value. So we're going to say we are going to add local here. Local is state scope local. So it's going to be a const with the binding. And then I need to have a place. Which is this original place from the value tuple field. So it's field place. And that's all. And then I don't do this. Okay. Maybe this will work. Maybe not, we'll see. Target dependent, inject binding. This is for the target, right? Because the target in this case is going to be... actually, this is going to be a runtime value. Scopes, add binding. So this is like state scope local. Okay, that works. Okay, next, Kast compiler. This over here, when I'm initializing inject binding, this is just going to be... What is that? Oh, like, yeah, so when I'm compiling for the interpreter, if the interpreter has some values inside, then we can treat them as constants. Well, interpreter local, yes. Okay. We're going to add const binding is this. And it's place. Place is going to be local place. And when I'm compiling a simple token right now here, now this is also going to be scopes find. This is going to be my local. And then I just need to say local compiler, local, like this is a place expression in this case. Span state. If I'm trying to do the identifier, then we are doing the claim, but I feel like we can just do directly the same thing, but it's going to be just local expression. Okay. LSP completion. Now locals is scope locals. What is scope? Compiler scope. Yeah, we are supposed to have the local here. I'm just going to say that binding is local compiler scope local binding. Success. Okay, is it going to work? It sounds funny. If it's going to work, yes, it doesn't, of course. So what's the issue? The issue is still the same. STD is not found. Wait, hold on. I did all of this, and this didn't work. Oh yeah, hold on. It's okay. It's because what we're doing. Let's see the way const let works, right? So it's this is part of the core syntax. When you do a const let, what we are doing is that we are a const let is still saying that I am assigning this to a runtime value. A value is figured out, and then I inject the pattern bindings, which means that it still is a runtime value, right? So instead of this, I need to so instead I need to so technically const expressions, they have any bindings, right? So like they have patterns. So we're doing pattern matching. So yeah, we are doing the pattern matching here. But this is a pattern, so I can like pattern match directly, right? Can I say interpreter pattern match? This gives me the locals. By the way, I'm doing the injection first and then evaluating this at compile time because we potentially like refer to this. Or something. Okay, I have a value here. I just need to turn it into a constant. I'm having a let here. Pattern. But I just need to do the pattern matching directly, right? Interpreter pattern match. Span. Place. place and pattern. And then the locals. Ba-dum. Maybe like after I evaluate, how about we do this thing? We do after evaluate, I go over the pattern bindings. Pattern bindings, right? I have a list of bindings and I'm going to find those in the compiler interpreter. Right? We have pattern, we have the bindings, and we just do a list iterate. We have a binding, and to figure out the actual constant, we say C state scopes add. We're just going to add the local here, right? So it's going to be binding, but it's not the binding, right? It's going to be a const binding. This is what I want, right? And this should be const where place is interpreter state interpreter C state interpreter interpreter scope find the binding name option get. Cannot use this. Hold on. Okay, but okay, hold on. We went further. Cannot use this. Use bool. Because bool is something. So this is in the core syntax, just use. Use. Cannot use this. Because this is what? Because okay, because it's not a binding now it's a constant, right? Because I'm compiling this as a place expression, but this is a place expression which is temporary constant now. That makes sense. Hold Hold on a second. I feel like this should be done differently. Instead of doing that, in order to use a thing, yeah, so this is a constant, but I lose the information about the binding here, annoyingly. Should I instead, like, of doing this, I should instead match on the syntax, on the ASTs here, if we are doing a field or just a binding, or just something. So the thing is that we are compiling this bool to a constant, which is the native bool type now, right? Which is a different thing than before, because before the boolean was compiled to a reference to this variable, a runtime variable, runtime being the interpreter used at compile time. But now it is compiled directly to a constant, which makes it no longer work. But that's good, right? We just need to change the implementation here. It means that I need to, like, not... Do I even need to compile this? Or, like... I mean, in case this is a single identifier, then we need to look it in the current... scope. Wait, how does this even work? This is a module. This is weird. It's because I cannot wait here, I think. Yeah. Module means that this is a recursive scope. So, like, when I say, like, boolean, it's trying to find the boolean in this scope first. Which means that this is using this itself, which is weird. But yeah. Well, I mean, we're doing this at compile time, so it's not in... Yeah, and we cannot wait for it. Or something. I'm actually surprised that this works. But yeah, so like I can basically make this based on the syntax, right? We have like two ways to use something. We either like use like string dot to string, which means that this is the thing that we need to figure out what it is. Or like in this case, we need to actually evaluate it, right? In this case, I actually need to evaluate it, and then I just claim. So yeah, I just evaluate it, and then I do this, right? Yeah. If it's not direct a binding and not a place expression, which means that it is a constant. Then I need to create a symbol based on like this. Like, yeah. I guess maybe I just do like two separate things. We are either using a thing or we're not using a thing. So I'm going to match used shape with. So like by default we're going to do that. But if this is simple token where token is identifier, right? So in this case, we are going to instead find this identifier in the current scope. We need to find AST hygiene in this case. Needs to also be done. From scope needs to be done. Hold on. We need to find hygiene is the AST. So this is the used data hygiene, right? Yes. From scope is state var scope c state. From is used data span, and label is going to be the identifier. So we're finding it, right? So let local be this. So now I have a local. No, I don't. Value that has type token shape ident raw. No, we have name here, right? Name. Kast compiler. Yeah, we just use identifier name here. So local is now the compiler local. And I just need to add this local here because it's the same local, right? So I just say C state. Add local. Only compiler. True. Local. And then in this case, this is going to be... Over here, I'm doing a const let. But I guess I just don't do anything, right? Const shape value unit. Something like that. Let's see if it works. Maybe? It doesn't? Why not? Am I going further though? Oh, I am going further. Hold on. So the standard library actually worked, but the DBG is now not found in the scope. Why not? So this is done with the standard library, right? Can I say like std dbg print hello? Was hello printed here? It was not, because I did not get to the thing. So std dbg works, but dbg did not work. There is something wrong with that. Oh wait. This still doesn't work. And now when evaluating, invalid argument tuple zip named. Wonderful. While evaluating this constant expression std. Huh? Instantiate the generic. Read place. This. Wait, wait, I cannot evaluate a constant? Because there's some unification here. Unite data. Why am I doing the inference though? Substitute bindings, that's why. Well, but it did compile, right? So can I like hover this? And it is like showing me the things inside of the standard library. It compiled successfully, but it could not run. And because tuple zip, when I unite value tuple here, did not work. Zip order A. Try with invalid argument. Try array combine. Wait, what's the actual exception though? tuple zip named, because this one is not found, because some is not found, right? But the finding only happens here, right? Yep. So we do try here. Try find this. Let's give me the names of A and names of B, right? Named make string. List print string print A named order rev. List print string print B named order rev. Going to give it the thing. All right, so here we go, right? We have the fields toString, print, parse, panic, input, eprint, dbg, /n. What? /n. Why is there /n here? Because the formatter probably like is limiting the length of the thing. You insert a toString option list into in64 float 64. So like this is looking like the prelude, right? And then this over here is that. Into list input eprint print parse toString. Huh? Wait, I know. I think I know. Or do I not know? I need to do something without the standard library test. Let's do this. With no standard library. I want to say like module const x is 1 to 3 is x. Right? Let's see what this evaluates into. Kast eval no std. So this evaluates successfully, right? Can I say now? Can I now say const foo is this? And can I say like foo x? That works. So the issue then is the something else. Something else is the issue. And it works like this, by the way. I need to literally use the standard library. Like this. Yeah, I just literally the thing that is breaking is the STD here. That's all that we need to break. Let's do the logging in the interpreter core. It's like I broke my modules, maybe. I don't know what I broke exactly. We'll see here. So when I have a constant, let's do this. Info, before sub, after sub, something, something. Yeah, so before sub, we did this. STD, unwind token, all of these things are here. Yes. And then I could not substitute monomorphized value. This could not work. Because tuple zip. Can you just like throw an error here or something? Can you just like try? With invalid argument. Then we just do the error. How do I do the error here? Dun, 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 dun. Value tuple. But we just return the as value A. I will just return value A here, I guess. I will return print value tuple, print value tuple. We'll do the try on the outside. Okay. Okay, so it says that value shape boolean is not equal to string parse print print this into over here. Okay, this makes no sense though, right? Because we inferred the type. Okay. I see this. Because I inferred the type to contain the Boolean field, but the Boolean field is never there. That makes sense. Okay, so the problem is the way I am evaluating it, right? The problem is the way I am evaluating it. Maybe I need to do... So like one of the fields that is not available here. No, Boolean. Wait, hold on. Yeah, we just have like some functions and that stuff. But like I don't have dbg, for example. It's weird. It's almost like it's RNG. If I say module const boolean is type is native boolean. We have that then. I do have like this is in my type. That's right. But the actual value does not have it for some reason. Why not? Why not? Or by the way, am I sure that it is this? Maybe it's the maybe this is just the prelude. Hold on. Maybe this is the prelude that did not work. It probably is. It probably is because yes, so the only things that are actually used properly. Okay, I see. Is this the last thing that I did? The core syntax. The last thing that I did was the use thing. So whenever we do the field, right? If we look at the prelude, so the only things that actually work properly is this: string to string, string parse, IO print, eprint, input, collections list, and convert into. Those are the fields that we have here, but the fields that we don't have are all of the other ones, which is this other thing. Okay, right? Because I need to say that. But that does not work. I need to actually do a const let here, and to actually do a const let because we want this to be still available as our runtime value. I guess, yeah, that makes sense. What the fuck is a const let? Well, it is introducing a constant. It's just a helper function that I have, which introduces a constant. So like the idea here is that when I introduce a constant at compile time, I also introduce this value as a runtime value too. So like we can use this thing both at runtime and compile time. And this is important when I am doing the modules, I guess. So I still need to compile this thing as a pattern. Which means that I still do this. Maybe I always do this, but in case it was a simple token, I just add the local like this. Is that what I do? Kind of cursed. Over here we say let result be this. Result. And then I'm going to match. And if it was a simple token used, can I call this used AST? So used AST shape. We're not going to do a const let, we're just going to add the local to the compiler state, and in this case I don't do anything. Right? Is this going to fix it? Now it says cannot use this. Oh yes, because this is now a constant pattern. Wait, it is a const let anyway, right? Hold on a second. I just need a const let. Like, maybe I can always use this. Just claim this expression and compile it to the place expression, right? Maybe this needs to be done over here. In this case, cannot use that. But in this case, if it's a simple token, then we have a local. And this is where I have like the binding, right? So this is my binding. Yeah. This is what we do. I create a p binding, where binding is local state scope local binding. Work? It worked. It worked. Okay, nice. What about the macro hygiene? Seems like something worked. Let's remove this excessive logging. So my macro hygiene example works now. Actually. And examples hello world also works. Okay, and then we test this on the advent of code. And the advent of code did not work. This is day 2. Day 2 did not work. Day 1 worked. Could not find toString in scope. Alright, well now this is also wrong. Let's go to test. So std is here, right? But toString is not available to me, even though this is supposed to be re-exported through the prelude. It worked though here, so why would it not work in the advent of code? toString hello. I don't have toString for strings, right? Yes, of course. For a char. Okay, so what's the problem with the advent of code day 2 then? while compiling, this toString is not found. Because it's like inside of a thing. For I in range in 0 to 10. Print toString I. Is this not working? No, this is working. Okay. Is it because there are like 3 different nested loops? What's the actual issue? Also, toString that is not found was this one, but there are other toStrings which are supposedly found. So this is not found, times is not found. Even though times is supposed to be this thing. This parse was found. I cannot go to the definition though now. Because this is a constant. Maybe I can... Let's fix this thing first. And then fix the LSP stuff. Yeah, I cannot find anything that is not from like the current scope. Weird. Oh, maybe this is a loop, not a for. Let's do loop. Maybe loop is something different for some reason. No, but this works. Okay, let's have the advent of code solution copied into the test. Maybe I can minify this. Obviously, I don't have the common input path. Input path is hello. Just a string. Part 1 is true. Yeah, over here, yeah, we still have the same problem. I can probably minimize this, x. I can just say that let mood x is 0. Right? So the issue is still the same. Max times is now not defined, but that's okay. I can probably like remove everything. Some of these things, let's just do 2 to 3. This is unnecessary. Input. Assert answers is not needed. We just do this. Wait, hold on. So this now found what toString is. It could not find it if I had some other stuff here, which is weird. This is still found. And now this is not found, but if I remove this, then toString is now known. Interesting. We have bugs. Can I get rid of this? And it still is not working. Can I get rid of this? So X is found. Can I get rid of this now? Okay, so as long as like this is not the only thing in this scope, because this is introducing an it's probably because this is introducing a new thing or whatever. So I don't need this, right? So we still have a bug. There we go. This is the minimal example. This is the minimal example. If I do this, then it works. toString hi. So this works and this doesn't work. Does it not work if I do this? It does not. Okay. Could not find toString in scope. Makes sense. Do I need a loop? I do need a loop. Which probably means that because this is a macro. So because there's a macro involved here. If I do add loop, then it works. Which is different. And not a macro anymore. Okay, so I guess the minimal example that is not using the standard library. Can I say over here, let x, let's like variable outside of loop is outside and I can just I just want to use this variable outside of loop. Yeah, so like this is not usable, right? If I do this, then it works. Okay. If I say if true, then it works. Actually weird. So what is the loop then? I guess. This is what it is. What if I inline it though? What if I inline it though? So this can be found, right? So the problem is actually with the macros. We do too much hygiene so that we cannot find the thing anymore. Okay. Syntax test. Let's do a test here. So so I can obviously do that, and this is supposed to also not work if we do the code like this. Wait, this works. Wait, what? This is the same stuff. Oh, wait. It's not the same stuff because one of these is done in the standard library and one of these is not. So like if I move the syntax definition over here, then it still works. But if I move this into a scope, then it still works. Isn't this supposed to be the same thing? What's the difference? If loop is literally defined similarly. I mean, the priority is different, 500. Does it matter though? Oh, wait. Loops, it includes the scope. I see. Maybe this is the difference. Can this be the difference? Because this thing requires parentheses here and here. So we do like code in parentheses now. And the priority of 500. Unexpected let. Oh, because this should be like any priority now. There we go. Wait, hold on. This actually is breaking it. Cannot find outside of loop in scope. Okay. That's changed something, even although it's almost the same. So like the difference is that this over here had parentheses or not. Right? So yeah. Whatever. So let's remove this. And let's remove some of this. So this is still broken. This over here. Yes. This is no longer broken. So it breaks when I do this evaluation. At compile time. What if I do this without even a loop? It still cannot be found. All right. So the eval doesn't work. Eval 2 plus 2. Eval 2 plus 2 also doesn't work. So it doesn't matter what I evaluate there, right? Does it need to be eval or can it be underscore? It seems like underscore is also so like literally just anything with a semicolon. And the reason for that is because I am compiling in this scope or something. If I have something before this. Why would this break? Okay, hold on. Hold on. Let's do this. Run no std. So this doesn't work. Because it cannot find it. And I bring back the logs on my scopes. Hello, Prishlyetsov. How's my language doing? I'm breaking it. I'm trying to fix a thing, but we result in the things being broken instead. So, something like that. I'm trying to work on the macro hygiene. And now the symbols cannot be found properly. It's almost working. I feel like it's almost working. Let's do some logging here. In the compiler state, we have the scope. So all of these info. So I'm trying to find, like, there's not a lot of scope that I have created, right? A variable side of loop. The definition side is 132, right? Because this is like our outside scope. But I injected X. Wait, what? Yeah, I injected X. X doesn't even matter. I injected X into 234. So into the same scope in which the variable outside loop was present in. The 132. Wait, but var outside of loop was injected into 174 where parent is none. Wait, what? Yes, because this is like the root scope. We have the root scope because this variable is in the root scope indeed. But I still have some scopes because this has the same parent on the previous one. Okay, hold on a second. Enter scope. Injected code into 132. X was injected into this. Parent is 132 because we're injecting into the definition site for X. The definition site for X is 132. Right? 132 is the scope where we have the code. But we have the code over here, which means that this makes no sense. So in the code is injected because this is a runtime variable for this macro to work. There's no macros involved here yet when we're defining this, so we're trying to find the code in the in this scope. $114 is the parent. 119. Yeah. So variable outside loop was injected into 174. 174, I don't even see this being created though, right? Because we're injecting, this is just created right here. So then I entered the scope. Why am I entering the scope actually? $211. Which is the definition site. Yes, we're entering the definition side of this macro because we're doing the test. So we're compiling this now over here. So we are in that scope. The definition side for X is 132. Injecting into the definition side. Wait. Shouldn't I enter the definition side back? Because this code is being inlined here, right? Oh, wait. I know why. I think. I know why. This is actually a little bit weird. It's because I don't like because I lose the information here actually. So the thing is, the semicolon is like a binary operator from the point of view of the syntax, but when I'm compiling it, I guess in the core syntax, it's called then, right? This thing. What it's doing is collecting the list of all of the like binary rule names then, and it combines it into a single AST, which means that the information about this original scope is lost, and we are now in this scope. Okay, this is a problem with the macros in, I guess, right now, because I'm losing the information. Unless I am going to mark with the definition scope every piece of the things here, then it's going to be fine. Yeah, so the idea is that if we have like, you know, A, B, C, right? This is being combined into a single expression, even although technically this is being parsed as A, and then B and C is like the second thing, right? So we basically have the AST, which is like B and C, is the AST, which is B semicolon C, but we are injecting this as like the AST directly here, right? So this expanded AST is looking still like ABC, right? And I don't like I'm basically I'm annotating this entire AST with the scope where it came from, but I lose this information once I flatten the list. So this list is stored originally as like a binary tree, and then we flatten it into an actual list of separate A's, B's, and C's. For that reason, I think I had in my compiler, didn't I have this thing, which is called init.ast def site. So this is introducing the definition site for the ASTs to be equal to the scope. If it is not set yet in the AST. Yes. So we don't delete this actually, and this is still useful. Which is we're supposed to use it in the quoting. We have expression quote AST. Dev site. Hello, Nerdcell. And I'm annotating this only in the definition site here. Yeah. Actually, I just do this everywhere. Like, not only if it is a root, right? If root, yeah, definition site is always going to be this. I'm just saying that the definition site is none. I was doing this for some reason. But is it needed? If true or root. Maybe this is all that I do. I don't need this thing still. Right? I don't need this thing still. I just annotate everything. Well, that didn't work. Now let's see again. Is the scope still the same? Well, I mean, so now I am like composing those. Still fixes it because well, I mean, I can just surround it with parentheses, but that's it's the incorrect solution, I guess. Could not find var outside scope and yes, over here I entered the definition site. This is the definition site, right? This is my AST of the macro, and I entered this definition site. But when I go back to the code, I need to enter the definition site back, is the idea, right? So yeah, where is my like Kast compiler? Enter definition site, right? Because the hygiene is the definition site. So I am entering this thing. Enter. So I'm updating. Def site ID. Because this was already entered, right? Okay. Let's do the logging here too. Entered already definition site ID. So the definition that I'm entering is this, and the result is this. So I entered this definition site, right? But then I entered the definition site that was already there for this unit. because this unit is defined in the same definition side as like this entire thing, right? So we don't need to do anything. Then we enter the scope here, I guess, because this introduced the scope, whatever. Then we enter the already defined side. Yeah, this is the the insides of the parentheses. The empty AST node is there, and then we're trying to inject into the definition side this, right? But why am I doing that if oh wait, what? That makes no sense. Like, I didn't even try to enter the thing. Oh wait, because this has none, because this is not the thing. Yes. This thing does not have, like, this is the AST that is, which is constructed not with a macro. So I don't actually have any annotation of the definition site there, right? But in this case, I need to like go back. Since this is from this place. I just need to go back to the original thing. Does it mean that my definition site is not even optional on my ASTs? Well, I mean, if it's none, you know, we have the definition site. But if the definition site is none, then I need to say that the definition site is like is actually none, right? I guess, because I need to enter the non-definition site. Is that correct? Do I need to say that this is like state with scopes? Is state scopes with definition side be none? Something like that. Is that going to work? It doesn't work. I feel like it would be a lot easier if we tried this on like a simpler language. Did this change anything though? Oh, yes, because now it's, yeah, now the def site is none. So we're trying to find in scope 111. But the var outside loop was injected into 174. But why is it 174? Parent is none. Why is 111 here? The the original scope ID. I want to know the original scope ID here. Yes. So we had the scope 111. We injected the var outside of loop. We have a new scope because like the new variable introduces a new scope basically. With that new variable. So the question is, I guess, why am I trying to find this in still in the scope of 111? And not in this scope, because I am inside of that scope now, right? Because over here, I entered the scope 111 into 215, what? Yeah, original scope is 111 here too, and over here is 111. It makes no sense. Test. Because this... Well, I mean, so this is just being flattened, right? We are inside of the same... So this is same as kind of like writing this code directly. But in this case, we're obviously finding the variable. And in this case, we're not. In this case, it works. Wait, hold on. But why does it work in this case? Why does it work in this case? Maybe I need to look at how the then is implemented. I'm just collecting the list and then I'm compiling them separately, right? That's all that I'm doing. Does the list map in OCaml guarantee that I am compiling it in order? Well, I mean, probably. Otherwise, everything would be broken, right? Mm. Boom, 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 boom. Wait, how does this actually work here, right? How does this actually work? How does this actually work? Is the question, right? So like on one hand, this is same. Yeah, like it's not flattening this thing because it's expanding the macro only when this macro is going to be compiled. So yes. Maybe because of that. What if I do the parentheses on the outside over here? It still doesn't work. Well, I mean, shouldn't matter anyway. Bum 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 bum. Do I just leave the stream once again with in the broken state where nothing works? Think about it a little more, maybe. Rewrite everything from scratch, maybe. Like if I try to do this thing in the what is that? Kast syntax reference. Drafting Kast expression. A Kast expression in C++ describes one or more location in the AST that you want your checker to target for target syntax issues. Over parenthesized expression. Why is it called Kast? What is this even? Which type checker to create? Kast or path? Kast checkers. Clockwork abstract syntax tree. Clockwork identifies critical security vulnerabilities and quality defects, optimizes peer code review, and helps developers create more maintainable code. Yeah, that's what Kast is about, right? Now you don't? Oh, hello, Dev Ninja. You want me to keep staring at my code forever until it works somehow? Fine, let's stare together. Boom, 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 boom. Okay, I want to do this. How about we do more logs over here? Kast compile. Whenever I compile this thing, I want to know what is my current definition site, whatever. Right. So we say like this: log, log compiling. With definition scope being equal to this at this. So span print span, and this is going to be id print And the ID is state scopes definition site ID. If you lose sanity with ask agentic AI. All right, let's see. So the question is variable outside scope, right? So let's go one by one. So I'm compiling this. All right, I am compiling this. The definition scope is 111 in this case, right? So I compiled this, the left-hand side of the equal sign. I compiled the pattern. I compiled the value, right? I compiled the value twice for some reason, but okay. Injected var outside loop into this. So we create a new scope 174. And now I'm compiling this, and my definition scope is 111. Okay, this is the bug. Because I have injected into this one, original scope is 111. So 111 should be replaced with the scope 174. Because that's what we do, right? And every time we see a new variable, because this is not a recursive scope, we create a new scope in which we have this variable. Right? Right. So why? Well, it is a no, it's not as simple, right? It's it was an expression. So it's like doing that stuff. When Kubi loses sanity, he rewrites. Or does a reading stream. I mean, we can do something else. I don't know. Play a game. I can go back to Factorio and lose sanity there. So I am losing this state, right? Core. Is this like my result? I don't have a result here, right? How about we do a let in the core syntax? I mean, then this over here, right? So I'm just compiling these things in order. C compiles, right? So it's supposed to like mutate my state. So how about we do this? Function AST, C compile AST, right? But we're going to say that let result is this, and then we return the result, and then I say like log info log after compiling this ast print ast dev site is this id print c state scopes dev site id. So after compiling this, right, the definition side is still 111, but that is wrong. Okay, why is that wrong? So we just do the compile, right? Okay. It's some stupid bug. like always, right? State. Oh, because I'm because I'm not mutating these scopes, right? This is supposed to be mutable, but I'm instead doing it the functional way where I'm creating a new state instead of mutating this thing. But this is a mutable thing, and I need to mutate it because otherwise I lose the information. That's right. Okay. So we don't do anything here. We don't do anything here. And over here, I say state scopes. Like this. And over here, I say state scopes. What's this? And it worked. Easy. Well, I mean, it's not necessarily working fully, but let's see. Yeah, something in the standard library not works. Nah, there's like some other bug now. We cannot find the X in this scope, in the for loop. Hold on. This is now, once again, the macro hygiene thing. Let's go to... no STD examples, macro hygiene, right? So macro hygiene is not working again. That's the same thing. It cannot find X over here. In the bottom one, in the 4, right? Because this let pattern be value, this over here. This over here. So instead of mutating it, you were creating a copy with updated fields. What were you doing with the copy? So I was using the copy to like compile the thing, but then I lost the information about the scopes, I guess. Which is actually very surprising that anything works. That anything worked. But I guess the only things that... yeah, it's actually like surprising that anything works there. Well, it's because I was only doing this if the AST that I'm compiling, like I was using either the original state or the other state. So sometimes I was mutating it and sometimes I was using the updated one. Yeah, which is weird. Okay, find another bug now. Back to this. So like when we had this, cannot find X in scope. It's because this let pattern be value is introducing this in a different place than needed or something. Wait. For X? Hold on, maybe I just need to... core syntax. In my quote macro again, like this true... our root is going to be uncommented for some weird reason. And then it works. No, it doesn't work because this is actually wrong now. So what's wrong? I need to re-enable the logs again. Make all of them be in the infos. So I'm looking for... Okay, the definition site is none. Wait, but why is the definition site none? In this case. The definition site of X... It thinks that the definition site of this is none. Which means just the call site. Well, I mean, it kind of is. Actually. So that's right. But where is it? You know, like injecting into. So this X is a different X. I wonder about this X. This X was injected over here into definition site 352, which is this. But the definition site over here was actually none. Oh, I see. I see now. It's probably because I am not... Yeah. In my Kast compiler, whenever I do the custom syntax, right? We have the AST here. AST, we have the definition site. There you go. Definition site. But I'm only creating definition site for the top level once again. But I want it to be for each, right? So this is where I actually use it. Right? This is where I am doing the cast. This is where I'm doing the compiler. Init AST, this one that I was going to delete. But I'm actually not deleting it, right? So I'm giving it the scope. And the scope is the current... Is it the current definition site? I guess. And this is the AST, and this is the AST. Is this? Maybe? Comment that. See if this works. First try, easy. It did work. Indeed. Okay, Kast. Seems like standard library was parsed successfully. Okay. I'm not going to explain anything to anyone because I don't understand anything myself. Alright? Back to trace. I don't want to see any logs. Let's go cast run the advent of code. Okay, day 1 works, day 2 works. Next. We're just going to wait for the entirety of the advent of code, I guess. I need to do it not like with only examples though, so it's faster to test. Day 6, day 7, day 8. Alright, maybe... Ah, shit. I was about to say that everything works, but it doesn't, because now we are in day 9, and it doesn't work. Unless I'm doing something wrong in day 9. Cannot find X in scope. This is the X. This X. For X and Y. Here. Right, this is, so this is because I am doing the destructuring, maybe? I can try that as an example. There's no custom syntax in this, right? There's not. Okay, let's go back to test then. So can I have like a list create. List push list X is 1, Y is 2. So this is supposed to be like list X int 32 and Y in 64, for example. Let's push back. For X in iterate list dbg print X. Okay, so that works. If I say like reference X, this still works, but if I say reference X and Y, then it says that X is not found. Okay. I see. So this problem is because of the tuple something core syntax tuple field over here, I think. So I have an inline thing. Maybe also, let me make sure. So like the full syntax for this is X is equal to X, by the way, right? So if I do this, then it actually works. And this is the definition. So this is just the shorthand syntax, supposedly, which is not working. Okay, so we have value is none. Right? So it is a pattern that we're doing here, a pattern. A pattern, value is none. So we are doing the var scope and we create a binding. And this is my value. My value is binding. I don't care about the value. Or no, hold on. Yes, we do have this binding. Yeah, the definition site is not none here in this case. This should be the label est data def site, right? And the hygiene and the def site is the same. Def site is none. I mean, this is in a lot of places, right? Def site is none. When I'm doing the use, this probably is also broken. Use.star Target dependent. Target dependent is okay. Yes, so use and target dependent. So like that's all that is not working. Okay, and this is now fixed. This is now fixed. That's all. All right, let's go again. Kast advent of code test. All right, day 10, day 11, and day 12, and liquid cake. And everything worked. Okay, nice. Nice. Node.js also potentially. Like, I was running this through the JavaScript transpiler. We can also try the actual interpreter. Also supposed to work. Okay. Nice. Nice, but I have a feeling that something is still going to be broken because I still don't like, I cannot, like the fact that I cannot explain it in simple words means that something is wrong probably, right? Depending if it's just a feeling or an actual bug. Yeah. Yeah, depends. Well, we're just going to write code at some point where I'm imagining that like if I actually start trying to do the self-hosting, we're going to hit a lot of bugs probably. Maybe, I don't know, like at the same time advent of code, it's like all still works, right? So maybe it's not that bad. But it depends on how much advent of code is actually covering. All right, macro hygiene, and it works. Yay. When your code base is 20,000 lines, even a feeling is bad. Maybe it's not that bad. Famous last words. I think maybe let's make sure. Like I feel like, yeah, dbg print. Can I do dbg here and like go to the definition of it? This over here is not working. I broke my my go to definition at some point. I broke my go to definition at some point when I was introducing the thing. Also, like dbg print is another thing where I'm clicking on this, but I'm going to the definition of print. A camel feels a lot less loose than Rust and Haskell, for example. Did you mean a lot more loose? Yes. Only due to the typing difference where Rust Haskell explicitly needs them. There are a lot of places where OCaml, where in my OCaml I'm doing the type ascription because the OCaml is too stupid. Well, it's not stupid. It's like the way its inference works. I just don't like it. Specifically for the variants and the fields. Like the fact that when you're constructing like a record, then the type for that record is inferred based on the fields that are inside of the record, and if there are multiple types with that, then it's using the last type with that field based on the first field first. Like it's just so wrong, in my opinion. But I mean, Haskell's the records are also really bad. I'm not sure which one are worse, OCaml's or Haskell's actually. Because in Haskell you also cannot have the collision between the record fields easily. You kind of can, but then it still sucks really. It's not wrong. It's one con of type inference. That's why you can circumvent it. Like, I would like it to just not do that. I would like the inference for the struct to work like it works in Kast. That is also the same as it works in like Zig, for example, as far as I understand. And although in Zig, like the inference is like a lot simpler, so yeah. This is why you should use type A is A instead of type A is this when you want to do records, and Rust has no other way of doing it. Yeah, I guess. Yeah, okay, I agree, I guess, right? If you have your type constructor, yeah. Just always have the type constructor to be named, but we are using the anonymous ones. But yeah, this is why Kast is superior to all three. That's right. That's right, because we can do anything. Although, like, one thing that I cannot do is I cannot do the OCaml's way of inference right now, right? So sometimes when you're writing a very, very small module in OCaml, right? Like, let's find something simple and small. I probably have something somewhere, right? Like ID, right? ID, right? So we have this thing, right? So we create a type T where the value is int, like this. Why is there a foo here? I think this can be deleted. So yeah, we have like T, and then when I create this creates this struct with this field. So I don't need to like annotate that this is T, this is done automatically. So in case of these small modules, it kind of makes sense to do the inference that OCaml is doing. But when more than one type is involved, then it becomes hard. When can we have a proper compiler then? You think do you think that the JavaScript transpiler is not proper compiler? What do you mean by proper compiler? Transpilers are proper compilers, in my opinion. Like, why is a proper compiler only the one that is doing the machine code? Need more big programs written in Rust, gain Kast through Rust. Yeah, I think that maybe I should try to do a game before self-hosting, right? Because self-hosting is going to, first of all, take a while. We're going to find some bugs, and we're not going to finish it. So before doing that, let's do some actual project. Because otherwise it would be a transpiler. But transpiler is a compiler. It's just a weird name. Like, transpiler, like, what's the definition of a transpiler? Because it results in the source code instead of the machine code, but machine code is the source code for the CPU, I guess. So it's just like you targeting a different architecture, a more high-level architecture of JavaScript instead of targeting x86 directly. And even then, no one really targets the native machine code directly, right? You are transpiling into the LLVM language, which is then compiling it. So does it mean that people who are doing it through LLVM are not proper compilers? Because you are not generating the machine code, right? Otherwise, I don't know. Is there like a JavaScript to native compilers? Converting JavaScript into native code. Native script. It's not a compile because you need a JavaScript VM to run right now. Well, I mean, and your normal, like, compiled code needs the CPU with the correct architecture and also the correct operating system to run it. How is that different from a JavaScript virtual machine? There's still a dependency, right? Like, what's the difference? What's the actual difference between a compiler and a transpiler? Cool. Okay, but like, so, but the idea was, like, why was I even going for the macros, right? We could write code without the macros, we could write code without hygienic macros, but I think it would be really nice if we were using this for actual code generation. Like I was starting to write examples, derive, right? So we have like reflection. I can have this where we get the information. This can be implemented natively, where I get the reflection based on the type. I give the type info, and like we just need to make sure that this is correct. And then we will just generate code based on this. This is the idea. I'm not going to do that today though, but maybe we can do it next time. Yeah. I think I should be done for today. Is a pre-draw vocal in VASDEVs can close to light song your voice? No, it's VAS probably. No audio. Bum, 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 bum.
The best form of communication. We need to get on with this.
All right. Oh wait, hold on. Lumersuno. Making a bash language. Let's go here. Right, see you guys next time. Thank you for watching. Bye.